During the Level 1 and Level 2 certification classes, we started to discuss the differences between Cleerline SSF fibre and traditional fibre. And for those of you who have used traditional fibre, it's essential to understand the differences in the termination process for Cleerline versus traditional, as there are several. It's also important to understand the benefits that Cleerline SSF brings you as an experienced fibre installer. If fibre is new to you, this training module will enlighten you as to the critical differences between Cleerline SSF fibre and traditional fibre, and show you that SSF is far easier to use than traditional, as well as safer to handle. If you're starting your journey into the category of fibre, you may very well be coming into it with the preconceived notion that it's difficult, or dangerous, or too specialised for most people to use. This module will explain otherwise and discuss how we at Cleerline have redefined fibre. To recap, SSF fibre incorporates the same 9 micron core as traditional single mode fibre and a 50 micron core as with traditional multi-mode fibre. Additionally, both SSF and traditional fibre then have 125 micron cladding around the core. The difference with SSF is it includes a very thin layer of polymer as part of its 125 micron structure. Protecting the cladding is a 250 micron acrylate layer which is removed during the termination preparation process. For traditional fibre, this acrylate is a hard plastic coating technically known as the primary type buffer, which is removed at a specific measurement along the cladding by use of special fibre strippers. For SSF fibre, this acrylate is a soft peel acrylate that is removed using only fingers. This reduces the skill and precision involved with the termination process and thus reduces the time and cost of labour. As you can see in the diagram, most traditional fibre also has a secondary buffer which builds the fibre construction up to a 900 micron diameter. This too is a tight buffer coating that must be removed by strippers at a precise measurement along the fibre for termination. SSF fibre doesn't require this layer as the strength and protection it provides is achieved with the polymer encapsulating the cladding layer. Once again, the elimination of this secondary buffer reduces the number of steps and precision required during the termination process. The 9 micron single mode and 50 micron multi-mode core sizes are an industry standard. With SSF's cladding being reduced in size and built back up to 125 micron diameter with the SSF polymer, it too conforms with the industry standard 125 micron cladding diameter. This means, although SSF fibre incorporates a proprietary technology in its construction, it's not a proprietary cable requiring proprietary connectors. For this reason, SSF fibre can be used with any non-SSF connectors that accept 9 125 single mode and 50 125 multi-mode fibres. There are several benefits that SSF fibre brings over traditional fibre, and those benefits are all covered in the SSF acronym. From an installation perspective, the fibre is much stronger than any other on the market. For the user, the fibre is far safer to handle than any other fibre, and from a labour perspective, SSF fibre saves a considerable amount of time when preparing and terminating versus traditional fibre. Let's walk through each. The mechanical fatigue rating of optical fibre is determined by placing the fibre under 3 different tests that simulate duress or stress for an extended period. The purpose is to create a standard value to determine whether the fibre can meet the requirements of an installation and survive under adverse conditions for a particular duration of time. The higher the rating, the stronger the fibre. Said differently, fibres with a higher mechanical fatigue rating are much more durable and less likely to fracture or fail. These 3 tests include a repeat bending test, a hot water test and an elongation test. During the repeat bending test, the fibre is bent over a mandrel hundreds of times to determine if it will illustrate microfractures or surface fractures. For the hot water test, the fibre is bent between 2 metal plates submerged in hot water which ages the fibre and is timed to failure or breakage. Finally, the elongation tensile strength test stretches the fibre to its point of failure. The results of these tests are put into a series of formula to determine the ultimate value, which is known as the ND value. Most of the fibres available today all meet the minimum required value of ND equaling 18. The more durable fibres in the market typically even meet a value of ND equaling 20. With an ND rating of 30, SSF fibre is proven to be far stronger than any other legacy fibre available and performs better under bend and pull conditions. In fact, SSF fibre provides improved bend performance by over 10,000 times that of traditional fibre and up to 3 times the pull force tolerance. Combined, these benefits give SSF fibre an extended lifetime of high performance and reliability. Additionally, SSF can endure a minimum bend radius of 2.2 mm at the 125 micron cladding layer. Compare that to Cat6, which shouldn't be bent down below 4 times its diameter, or approximately 25 mm, 1 inch radius. One last benefit, as proven by the tests conducted, is the enhanced installation pull force tolerance of SSF fibre. With a maximum installation pull force tolerance of 225 pounds when utilising the aramid strengthening yarns, that's 9 times the tolerance of category 6 at 25 pounds. Now, these lab tests and complex mathematical formula are all well and good, but what does it all mean for you, the installer in the field? Well, let's take an actual look at the differences between SSF fibre and other fibres that utilise a traditional construction. This video clip demonstrates the bend tolerance of traditional fibre compared to that of SSF fibre. You can see here that both fibres have had all of their buffer coatings removed, and we're looking at the 125 micron cladding layer. In the case of the SSF fibre, the 125 micron diameter obviously includes the polymer. As the fibres are pulled simultaneously and the loop becomes smaller, the traditional fibre breaks at around about 15 mm per the manufacturer's specifications. SSF fibre, however, continues its tolerance for bending until around 2.5 mm per Cleerline specifications. Having a high bend tolerance may cater to an impressive demonstration, but you're obviously not going to intentionally tie your fibre in a knot as the video showed. You are, however, going to encounter potentially tight corners, and even worse, you may unintentionally kink the fibre during installation. Tight corners are going to induce attenuation in any fibre, but as we learned just now, SSF fibre has a far higher tolerance against failure around those corners. More importantly, if the fibre is kinked during installation, there's a significantly reduced chance of breakage with SSF fibre versus traditional. Watch what happens to the attenuation in the traditional fibre after it's kinked versus SSF fibre. As you can see, the traditional fibre is permanently compromised, whereas the SSF fibre returns to its original performance after the kink is released. I'd like to preface this next part by mentioning that you should never poke yourself with optical fibre. As we know, fibre is made of glass and it can break very easily, especially when it's only the diameter of a human hair. For this reason, extreme caution must be taken when handling traditional fibre, as it's possible to have shards of glass break off and potentially penetrate soft skin tissue. The safer element to SSF fibre comes as a result of its smaller cladding diameter and the protective polymer encapsulating the cladding all the way to the tip of the fibre strand. SSF fibre will not puncture soft skin tissue if you inadvertently touch the end, so this not only provides a safer working environment for the technician installing and terminating the fibre, but gives a safer solution for the end client. Finally, let's discuss the labour-saving benefits to using SSF over traditional fibre. These two side-by-side videos will walk you through the preparation and termination of traditional OM3 fibre in a 3mm jacket with that of SSF fibre and compare the differences in the various steps while explaining the reasons and benefits to those differences. The first thing to note is the difference in tooling needed for traditional fibre termination versus SSF fibre. Please ensure you wear safety glasses when handling traditional fibre. Also, the availability of cleaning wipes and ethyl alcohol is necessary with traditional fibre, but is not required for SSF fibre. The first step in preparing both traditional fibre and SSF fibre is to remove the strain relief boot from the connector and place it over the 3mm jacket. Using fibre strippers, the removal of approximately 2 inches or 50mm of the 3mm outer jacket from the traditional fibre and SSF fibre is required. In both cases, this is done by use of the largest hole on the tri-hole strippers. For traditional fibre, the next step is to use the 250 micron hole on the fibre strippers to remove the coloured 900 micron type buffer. This is done in 5mm increments until only 14mm of the 900 buffer remains exposed from the 3mm jacket. Next, using the 125 micron hole on the fibre strippers, remove the 250 micron white or clear acrylate in 5mm increments up to the 900 micron buffer. For SSF fibre, do not use strippers but only fingers for this step. Placing the 250 micron coloured soft peel between fingernail and pad, gently apply pressure and scrape the soft peel off the fibre to within 12mm or half an inch of the 3mm jacket. For traditional fibre, it's now necessary to clean the glass cladding by using ethyl alcohol and wipes. This step is not required for SSF fibre, as the cladding remains protected by the SSF polymer. Once the fibre has been stripped, and in the case of traditional fibre, cleaned with ethyl alcohol, place the fibre into the cleaver, ensuring it lays flat across the two black tension plates. For traditional fibre, the coloured 900 micron buffer should be lined up with the 10mm mark on the cleaver. For SSF, the outer 3mm jacket should be lined up with the 24mm mark on the cleaver. Cleave the fibre, and for both traditional and SSF fibre, appropriately discard the piece of fibre that's cut off. At this point, it's important not to touch the cladding of the traditional fibre, as contaminants from your hands may compromise the glass. SSF fibre, however, remains protected by the polymer, though care must be taken not to touch the cleaved end face at the end. With the 1.25mm adapter situated in the VFL, remove the dust cap from the LC connector and slide the connector ferrule into the VFL. Turn on the VFL and observe a red light from the indicator window on the side of the connector. In both circumstances, ensure the activation slide tab on the connector is in the open position, such that it is located towards the rear of the connector, closest to the hinge. Carefully remove the prepared fibre from the cleaver and gently insert the fibre into the rear of the connector until the light from the indicator window extinguishes. For traditional fibre, this step must be taken with extreme care to avoid breaking the fibre inside the connector. For SSF, apply forward pressure such that the fibre exhibits a slight bow. While maintaining the forward pressure, slide the activation tab fully forward towards the front of the connector until you feel a slight click. With traditional fibre, maintain enough pressure for the indicator window to remain dark while sliding the activation tab forwards, but again, be certain not to apply too much pressure. Once the activation tab is locked, check that the indicator window remains dark. Should there be any light at this point, release the activator tab, reseat the fibre, and lock the tab again. Light from the window indicates loss and possible failure in the termination. For both traditional and SSF fibre, ensure the fibre relaxes in the back of the connector and lays flat in the groove such that the hinge will not trap it. The Kevlar strength members should be splayed out to the side of the hinge. Close the hinge and screw the retaining boot onto the connector just enough to capture the Kevlar, a half a turn or so. Once you have secured the Kevlar into the connector, take the shears and trim as tight as you can against the connector, and now tighten the retaining boot down and the termination is complete. If you were to record the process and compare the time taken to prepare and terminate traditional fibre versus SSF fibre, you'll notice a significant time saving with SSF. The use of SSF fibre versus traditional fibre returns a labour savings of between 30 and 50% while resulting in a more reliable and durable installation. Now that concludes this module on the differences between SSF and traditional fibre. Should you have any questions or need any help in any way, please visit our website at www.cleerline.com. See you next time.